Right, product and quotient rules. We are continuing that, and then we will start new material today. So first of all, we have the quotient rule, which I told you about, and we will talk about how to derive that only after we know the chain rule. So in many calculus classes, you would already know the chain rule by the time you knew the product and quotient rule. So that will be coming very shortly. What I want you to do is, I have the answer ready on the next page. We're not going to write this all out, but I want you to pause the video and do this and then come back and see if you got the answer right. Okay, did you go and come back? Great. Hopefully you did. And so now the answer is right here. Because I'll put the question and the answer together, I guess. Put this guy down here. And change his color so you can see him a little better. There you go. So you can just pause the screen and look at that. Okay. I'm assuming you will figure that out. There's a little trick that people use to remember this. They call this high, and this call this low. And most people remember that it's the denominator gets squared, but they forget which thing gets the derivative. It's a very silly little memory trick. We say low D high minus high D low. This is the derivative of the denominator. This is the derivative of the numerator. So if this little thing helps you, low D high minus high D low, then go ahead and say it. I mean, I didn't learn it that way, but a lot of my students would say that, and I think it's kind of cute, so I'm passing that along. Okay, next type of problem I want to go over is what I call product rule puzzlers. Like NPR's Performance Today, they have piano puzzlers. Well, these are product rule puzzlers. Okay, so what we do is we give you a pile of information. So like, for example, f of 2 is -3, f prime of 2 is -2, and then we'll say g of 2 is 4, g prime of 2 is 7, and then we'll ask you to find the derivative of this expression at 2. Alright, so we'll do that. And okay, it doesn't want to draw lines, but I want to draw lines. Fine. Okay. And so what I'm going to do is I'm going to first say, well, what does this mean? If I have a function g over 1 plus f, and I'm terribly sorry, I didn't mean to put squared, you must be confused. I meant to put prime, meaning derivative of. Okay, so I want to find the derivative of this mess. Actually, I could have found g over 1 plus f squared. That would have been fine. I would have calculated g of 2 over 1 plus f of 2. Once I got that fraction, I would have squared it. That would have been fine. But we're going to actually take a derivative. Okay, so in order to take the derivative of this mess, we're going to go 1 plus f and square it. So that's the denominator. So we're going to start with the denominator up top, and then we're going to say g prime minus g of. Now, what is the derivative of 1 plus f? Well, the derivative of 1 is 0, and then the derivative of f is just f prime. So we have this expression here, and we just have to pop everything in. And so it looks like it's really, really awful, but it's not really, really awful because we have all the pieces just sitting there. 1 plus, so this is all evaluated at 2. 1 plus f of 2. So it's 1 minus 3, and we're going to square it. And 1 plus f is, again, 1 minus 3. G prime is 7. G is 4. F prime is -2. You put this all together and you can figure it out yourself and see if my arithmetic is right. But it should come out to -3 over 2. So the technique is, so what do you do? I'm going to just type this out so you can read it. Okay, we are going to we're going to take deriv, but use f prime and g prime when you need to take the derivative of f and g. Finally, pop in all the data given in the problem. Okay, that's all you need to do. So you should hopefully find that pretty easy. Another style of problem that I can give you that's similar but not identical, but it's the same tone, is just like this. Okay, if I have f of x is e to the x times g of x. Alright, and it's like, oh, okay, well, what's g of x? I don't know. But g of 0 is 2, and g prime of 0 is 5. And I want you to find f prime at 0. Okay? So we're going to just take all that information and we're going to assemble it. And so the procedure says take the derivative, but we're going to, and this is the product rule is next. First times the derivative of the second plus the second times the derivative of the first. Okay? And we want to find f prime of 0, so e to the 0 times g prime of 0 plus g of 0 times e to the 0. E to the 0 is 1. That's not too bad. G prime of 0 is 5. And g of 0 is 2. So that answer is just 7. Alright? Another one. Okay. What if I say f of 2 is 10, f prime of x is always x squared f of x? Do not ask me what f is, because I will tell you and you don't want to know. Okay, so the question is find f double prime of 2, and here's how you do it. You just say, okay, what's the procedure? I just go ahead and take derivatives. See, I'm going to start from here, though, because I already have one derivative. And so I'm going to take now the second derivative. So how do I find the second derivative? Well, I just take the derivative of the first derivative. So the second derivative is literally the derivative of the derivative. Okay? So let's go ahead and take the derivative of x squared f of x. So this is the first piece, this is the second piece, so it's first times the derivative of the second, second times the derivative of the first. So f double prime is first times the derivative of the second plus the second times the derivative of the first. And you're like, okay, how does that work? Well, it's not that bad, right? It's x squared, and we already know what f prime is x squared f, and then f times 2x, and it's going to be f double prime of 2, so you're going to get 4 f of 2 is 10, f of 2 is 10, 2 times 2. And all that stuff, we put it together, we get 160 plus 40 is equal to 200. See, this is why I call them puzzlers, because I think they're kind of fun. You don't have to do all the nasty stuff that you're going to have to do later on. I didn't say that. It's never nasty. It's fun, right? But honestly, these are just kind of cute. So hopefully you'll enjoy some of them, and you will be not put off by them.